And even I remember when I started thinking of, is this something that is reasonable to teach children? And I asked in a group of adult pedagogues, actually headmasters of schools was this group. And I told them about how I worked with that. We had these focus groups. You maybe recognize the type of work together. Each person takes a turn to present a problem, and then the other gives feedback. And I really wanted to hear others' opinion about symbols and the way I worked on it. So I tried to describe it and ask this group of nice people whether about their reactions. And they looked at me, and well, people are polite, you know, but honest, that as they should be. And I really got the understanding that, okay, symbols is a very difficult concept. And you speak about small children. We don't think that's a very wise thing to do. But both actually in the following procedures with these kids and later with other kids, I'm pretty sure it is a good idea, actually. And kids learn it and they use it in their minds. So just let this question be on as a kind of punctuation for this small session about symbols. Look at the word ice cream, the logo of the Czech football club. It is Czech, isn't it? And also the Liverpool, which is recognized throughout Europe and probably the world. So how are they similar? I try to make them not similar, but we can see any similarities, some similarities actually. But you will know the important similarity that I'm actually with kids, I would keep asking until they see the right thing. But my experience is that even with the most complicated concept, when we work through associations, through discriminations, and also through generalization tasks, the children, they will know and they will learn and they will use it. So the next multi-digits multiplication and written multiplication below. And of course, I perceive this, I understand this according to my own experiences. And I haven't had a possibility to really study Czech textbooks in mathematics, as this course or these webinars have been planned in quite a short time as an end activity of our common project, led by the Matematic speaker. So that's why these pictures are recognized by they demonstrate the Norwegian methods. But as I said before, even if the way to note things and the reminders you note can be done in a little bit different manners, I would think that the real content in this and the ways of doing it also is more or less the same. Here you can see the calculation. And what is said here is exactly what we do. We clear up, we count the ones in one group, and we count the tens in another group. And we have 6 ones, and we have 12 tens. And when we have 12 tens, that's when we can make 100, which gives us the answer of this 6 units, 6 ones, 2 tens, and 100. the normal way of saying this by Norwegian teachers would be to say, okay, 3 times 2 is 6, 3 times 4 is 12. Okay, we can write 12 before that, and then we have got the answer. And that's the normal way in Norway of teaching this. But it doesn't necessarily, my criticism of it is that it doesn't necessarily tie the child knowledge to reality and to real numbers. And that will also restrict their possibilities to use this for their own problem solving. Again, multi-digit multiplication and written multiplication below. And I understand that as the way we do it here, to write the reminders kind of below the original calculation. And every time we need to make it. And of course, it takes a lot of kind of fuss. And I know a lot of teachers, they hesitate giving children tasks like this because everything gets so chaotic. And it could do that. But in particularly when you start when they're smaller, to work in such ways, it's possible to make routines that helps the children to keep in order, kind of, and to get things done without a lot of fuss and a lot of and after all, as a teacher, you know who of the kids is it that is in risk of dropping out and doing something else, and to give those kids some important tasks like carrying this material or looking after shutting the door or whatever is necessary to do in the situation. That can be one way of kind of keeping them in the situation and also keeping their interest and motivation going. It's also reason to believe that when we do activities that helps the children's learning, they will learn better and they will perceive that themselves. And in itself, that will be a motivation. And of course, if that is not our experience, why should we do it? Then we must do something else. If we don't succeed, if we don't facilitate children's learning in the activities we choose to do. On the other hand, kind of this need of being comfortable and not making trouble for themselves should not restrict us if some of the kids could have, if it could be useful for some of the kids to work in with real things. I remember I was replacement for one of my colleagues once, that was in the 4th grade, and they were working on division with multi-digit numbers, or maybe it was fractions, probably it was fractions. Anyway, it was about dividing things in real life, like a sheet of paper or a square of paper, or to cut out a round of paper and then divide it in 4 equal pieces, and activities like that. And we can recognize that as something you do when the children are going to learn something about fractions, for example. So and the kids, it was a small class, very small class actually, and the kids were a little bit confused, and they asked, I don't understand this, what is it that we are supposed to do? And I referred to these tasks that I saw was already passed in the book, and I said, remember what you did here? Yeah, but we haven't done that, the kids said. The teacher told us to just jump over it and not do it. And then I get I'm a little bit sad on behalf of those kids, because if we omit such tasks, we kind of restrain the learning of the kids. We prevent the learning and doesn't support it the way we have the possibility to do. Again, we clear up, and we have a large number of ones and a large number of tens. So it's quite some work to organize it and to make tens out of this. It's not necessary, when the children have got the point here, it's not necessary to put them in rows like tens. It's enough to just count them and replace them with a 10, which is much easier to count. And all these that here is put in rows, they can be changed in a real 10, and that's much easier to work with. So we start with the ones, and we have 2 ones in each. No, excuse me. We have 4 ones in each. And actually, we can discuss if the notation here is really done according to, well, yes, it is. We have, when we count all these ones, we have 24, 48 ones. And we can see here 4 tens and 8 ones. So we have, and then we have afterwards the tens, and then we have 24 tens as well. And we write the 24 tens like here. I'm going to show you afterwards some divisions in which happens something like that here now, because we have 24 tens actually, and suddenly we have written a 0 here. I don't know whether you usually write this 0 in calculation like this. Actually, in Norway, it's not usually not done, and that is confusing for some kids who then will struggle with the columns and not be able to calculate accurate. What we do with putting the 0 here is telling ourselves that now we speak about 24 tens, not about 4 ones. So this 0 that we put in here is a reminder of that. Does it make sense? Yeah. And then it's easy to add all the ones, all the tens and the hundreds, and you have the answer. And we, of course, maybe should recount here and see, does it make sense? Yes, we have 200s. We could have replaced them with a plate, of course. We have 1, 2, 3, 4, 5, 6, 7, 8 tens, and we have those 8s. So this is a way of ordering and calculating. And as you can see, when we work in the real world, it's much more about clearing up what we actually have got and sorting out what kind of units is it that we have, instead of just some mental calculation that actually requires a level of abstraction from the kids that maybe not all of them have the experiences and the knowledge prerequisites to be able to do. And that creates struggling. And again, ADHD is something that follows through these 2 days. And those children with ADHD, they are easy put out of the situation and lose their temper and their kind of energy to get things done when they are not sure, and when they struggle a little bit, and maybe it's like this, or maybe it's not like this, maybe I rather should, then they can't do anything. So this helps them keeping on the task and going to the real numbers and back again to the digits and the written numbers. And it isn't more mystic than that. That's what it is about. And then the same with division. And in the 5th grade, that is set like multi-digit division. And you can see here, there is used these small cups of plastic, and they have got a face on them with a mouth and a nose and two eyes, just pretending that these are those who are going to share this. And we have to divide what we have among these. My experience is that it functions very well, in particular when we're working with a small group or with one child, but this can also function and be a routine in a group where the children are bigger. This is one way, number of other ways that we can divide in and make a context to make it happen. So while in other calculations, like both in the addition and the subtraction and the multiplication, start with the ones. We start with the smaller units and then we connect them together in bigger through our processes towards the answer. But that's opposite when it comes to the division. I think that must be the case also in Czech, and the way you do these calculations in Czech. And one reasonable thing that fifth graders also will find reasonable is that, of course, we try with the biggest items first, because everybody will have as much as possible. So it's quite reasonable to start with the tens. See how many tens is there to reach. And that's quickly done. And we can also calculate what is it that we have left. When we have distributed 4, we have just 1 left, which is easy to cut, not so easy to cut 4 pieces and distribute. So we need to change it. We need to change it to 1s. Then we have another number of 1s to work with, and we can distribute it to each of those. I think you through the pictures can follow this reason. So fifth graders, for the sixth graders, written division by a 2-digit number. So what was the word again? Multi-digit division. But division by a 2-digit number. Maybe that means actually that you should divide it on a number that is larger than 10. Could be. And in that way, this doesn't answer to that. But if it necessarily, if this has been done so that the kids understand the division with the multi-digits in the dividend, then it's not that difficult for them to do the division also with larger numbers. But because when we also have are going to divide by a 2-digit number, we need a lot of stuff. It takes a lot of space, and that would be reasonable to do maybe on the floor with the kids around, and each helping with different things. Somebody's writing the numbers on the board and so on and so forth. Might function, but it might be not so necessary if the children has learned and understand what is it that we do. And I will show you, yeah, here is another, just let me mention that first. Let me see. or back to the previous one actually. No, we are going to return to this question and also to the division when we are arriving at decimal numbers. That will be the last thing today. Some math books, reasonably enough, also demonstrate how there is a kind of a line from the 9 divided to 3 to 90 divided to 3 to 900 divided to 3. And that's also very easy to see when you work with concrete materials, because you have the same number of items, but they have another function and another name, and they are the notation of it is